is your RMO problem 3. Problem number 2 is number theory. And you want to show that 7 divides for any n, okay, greater than 7. 7 divides n choose 7. We usually in India we write like this, at least in high school. It doesn't matter. N choose 7. And then there is this symbol. This is the greatest integer not exceeding x. So it's the floor function, taking the integer part. So you should usually be denoted like this, better than just writing a full box, and there's a confusion. Interesting, right? Prove that this is divisible by 7, and choose 7 is this. Yeah. So just to make it clear for everyone, I mean, n choose 7 is what, right? It is number of ways of choosing and so on. That is there, and so it's the number of ways of choosing 7 things from n things, and distinct things, 7 distinct things you have to choose. That you can use in the problem, right? But there is also the more standard thing, which is there is also the algebraic thing, which is this. So it's going to assist, but there are 7 factors you can see. And n is bigger than that much bigger. N is so again, I don't know how to do this. Let's try this. If anyone has tried this. Okay. So do you check it for n equal to 7? For n equal to 7, the number is 0, right? 7 choose 7 is 1, and 7 by 7 is 1. So it's 0, so it's true. 7 divides 0. But you have to show it's true for all numbers. Yeah.
Sir, in the numerator, we have 7 numbers, right?
In the numerator of n choose 7?
And yeah.
Yes, see, there are 7 factors, right? You can see. So it's a dot, dot, dot. So yeah, it's n minus 1, n minus 2, n minus 3 till n minus 6. But it's 7 things. N minus 0. Any ideas? You can also try to just do the, if you're not getting any ideas, I'm just saying, try for 8, 9, 10, see what is happening. It is true, but how is that truth coming about? Unless you do the calculations, maybe it's difficult to see. Try for n equal to 8, 9. I also don't know. I'm thinking. When I'm just thinking, but you should not be just thinking. You have to also do calculation. I'm also doing, but you have to probably do more calculation. You have to see that.
Sir, can we say that numerator of NC7 will always have a multiple of 7?
That is true because it's an integer, right? NC7 is an integer, right? If you, maybe we have not proved it officially, but that's an integer. Because there are 7 consecutive numbers in the numerator, right? And so one of them has to be divisible by 7. Similarly, one of them has to be divisible by 6, one of them has to be divisible by 5, one of them has to be divisible by 4. Well, but still the whole thing is divisible by 7 factorial. That's interesting. It is still interesting with that. It's not easy to, maybe it's not, doesn't follow from what I said so far. But let's assume that is true. Yeah, that's yeah. So don't get into why it is an, why n choose 7 is an integer. Okay, let's assume that. Right. It's not difficult to prove, but maybe we can discuss this after. I'm just wondering, does it have to do with the number 7 or is it true with any prime? What? It's got a fluke problem. It's not. It has nothing to do with 7, I think. Anyways, this will. I don't know. This might need little more preparation than we have. Okay? Let's discuss a few matters that this will need. Okay. Yeah, maybe we are not completely ready for this question. Yes. And then we can look at the solution if there is a easier way than anything. Anyone has ideas so far? Any ideas? No. It's a I mean, how do you understand this? That'll be some easy questions. How do you understand this number theoretically? Right? In the sense that you would want to know this is congruent to what modulo 7? Well, obviously, there's no way to answer that as a number because n is not given as a number. Right? But will depend on a certain feature of n. First, what I'm trying to say is that we are trying to understand the remainder that n by 7, this floor, leaves when divided by 7. That's what we mean. It's congruent to x mod 7. This means that 7 divides this minus this, x is the remainder. I mean, yeah, it doesn't have to be the remainder, but it's like they're almost the remainder. So this, right? So this is the remainder, but then you can write this also, right? So 15 is congruent to 8 mod 7. So these things you don't know. Well, let's just think, how do we understand this x? What's the natural? So in general, the thing is that to understand this thing, it's better to write n in the form of 7, right? In the form of 7 means what? What do I mean by it? I mean, there's no official word in the form of 7. In terms of 7, we write it. Now you see something good happen. Right? This is just the quotient remainder business. What is this? Is it q?
An integer.
Yeah, right, Cindy. Is it q? Yes, right? Because q is an integer and 7 is a fraction. I mean, r by 7 is a fraction. R by 7 is a fraction, right? Because r by 7 is less than 1. R is less than 7. Right?
Yes.
So you see, the natural way to break n by 7 into an integer and a fraction is like this. One natural way. And that's so that floor of n by 7 is this q. So my point is that it doesn't computationally tell us what is n by 7 or what is floor of n by 7 or what is the integer part. I mean, there's no way to know that. But at least it has given a more number theoretic meaning to n by 7. That q that you're looking at, that is n by 7. See, that is what I'm trying to say. This is a good thing to do. Basically, every time we're looking at numbers, these are just quantities, right? But we are trying to understand the numbers by simpler quantities, right? And that's why we have to put a correct framework to understand a large number in terms of easy quantities. For instance, the number 100. Now, suppose you did not have the digit system, right? You didn't have the digit system. Let's say you had different symbols for every number. Then by the time you get to the 100 number, you have some new symbol, right? So then there is really no way to do any calculations. You would still know that this symbol plus this symbol would be this symbol, but then all of it would be sort of like a memorization, right? But then you break the number system sort of in 10, and so so you first 9 digits you say same, but after that you say no, this one we are going to denote by this 1 and 0, right? And then you introduce a system. So you read off it. If you see a number like 1, 2, 3, then you read it off. Okay, there was 3, then came 20, then came 100, and that many things is this number stands for that thing, for that quantity. But that is a way to just to break up that number 123, which is not 123. We call it 123 so many times that now it looks like it is, but it's that huge number that comes at the 123rd step. But we have a very simple symbol for it. Even when I say 123rd step, I'm still using that fact. But the point is that the digit system simplifies things. The digit system is just one way to simplify it. This is like taking the number n and simplifying it using this thing in terms of the quotient and the remainder. This is just putting a different framework for this different purpose. For some purposes, you may have to put a binary expansion framework. You write it in terms of powers of 2, like computers like that more, apparently. Right? So it's the thing, I mean, putting the correct plot of coordinates is what mathematics is trying to do. Right? So here, when I put this, then I get this this it has a meaning. Okay? So this is fine. It's n by 7 is congruent to q. Obviously, q is not less than 7, but you know, it's the difference is divisible by 7. What do you understand? I mean, sorry, n by 7 is equal to q, right? What am I saying? It is actually equal to q. It is more than n is 7q plus r. Now, what do we want to show? Now, our job is to show that this n choose 7, let's write it in full. And then there is a huge, apparently scary, I mean, seems like how do we work number theoretically with this kind of massive thing? Right? This is congruent to, what do we want to show? We want to show this is congruent to q mod 7. We want to show that q and this number leave the same remainder, because that's the question. That is the question. Right? Is it clear so far? And this is just this, I have just, it's not needed to write mod 7. Just saying that this minus q is divisible by 7. That's all I'm saying. Because this is q. But we'll do this because it will help us to facilitate the computation of the remainder. So we are now what do you do with it? We don't know. Again, simplify. Okay. Now, see, you may see he's doing so many things like simplify this, consider this. Point is, you may think this is a very tiring thing, but see, I'm just doing it faster because I've been doing it for a long time. So once you do it, also it will become smoother. Okay, so don't worry that so many case works. Yes, but, yeah, I've been doing this process becomes smoother. Okay, so don't worry, or don't be too hard on yourself that you're not able to think of. So this is n is 7q plus 1. Right? I will simplify the question. Simplify the question, right? Or means find the question, then let's simplify it. Let's say n is 7q. Let's say n is 7q. Even then, the question is not obvious. Do you notice that? It's not obvious yet. If n is 7, I mean, if n is 14, is it obvious for anyone? It is obvious that 14 choose, I mean, it probably becomes more non-obvious when you put numbers. I mean, right? Is this obvious that this is divisible by 7? No. To me, it is not obvious. Right? So it's not so easy in that way. At least I'm not able to see the easy way. But we are going to just use that practice 7q because see, I mean, once you have written here, you have written q. Why are you writing n here? If I keep it like this, are you going to learn any, I mean, get any insight from this? No, right? You have to write both in terms of q, maybe, hopefully, right? So we do that. That's all. So we're not going to do anything. Just replace n by 7q. Not so. I have not done anything so far, right? I'm just rewriting this thing in terms of q. So again, just doing the easier question. Just doing it for n equal to 7.
Are we assuming n to be a multiple of 7?
Yes. So just assuming. So there will be other cases left. Yeah, but as I'm saying, I'm doing a simpler problem. Okay. Always you have to I mean, last problem also I was trying to simpler case, right? 1, 1. Then I got some idea. And just because I don't have an idea, so let's take n equal to 7 q, probably simplest. Yeah. So here also I could have done that, and q is obviously done. Always do the simplest thing first, and then soon you will be doing the hardest. You will be able to do the hardest thing first also. Okay, but then the problems will also become difficult. So I mean, you'll be stuck in the same place relatively. The point is this: now how do we simplify this? Well, the easiest thing that comes to mind is make this 6 factorial and remove this 7. What do we want to show? We want to show that q is we want to show that this left hand side is q mod 7, right? We want to show that this is q modulo 7. We want to show that it leaves a remainder q when divided by 7. What does it mean? It means that I want to show that this thing leaves a remainder 1 when divided by 7. Does everybody agree to that? If I can show that that leaves a remainder 1, then am I not done? Yes, right? Okay. So that quantity I'm going to show is leaving remainder. And all these I'm getting it's becoming smoother because of the congruence notation, right? Because I know this is remainders behave in this nice way. So I prove that remainder is 1, product has remainder 2 times 1. So my job now is to just show that that quantity has a remainder of 1. So I will not remove anything, just move here on the forward. Yeah, I want to show, so now just keep your focus on this. And we'll try to show that this leaves a remainder 1 when divided by 7. Okay. I know this thing's a little difficult, but see, this is also an integer. Because again, there are 6 things on the top, and there is 6 factorial, and there are consecutive 6 things. So this will be an integer, that's not a problem. It's not a problem, right? So let me do it on the next board. No, here on the right. So, I mean, okay, fine. Let's forget the denominator also for a second. Can you show that the remainder leaves what remainder does the numerator leave? Forget the denominator. What remainder does this numerator leave? Can you say when divided by 7? 7q minus 1, 7q minus 2. What remainder does this leave when divided by 7? Only hint I can give is it's not different. What is the remainder when this is divided by 7?
6 factorial.
Yes, right? So because everybody sees, right? Because remainders behave in this nice way, right? In the nicest way you can imagine. Right? But this leaves remainder minus 1. Okay, that's true. This leaves remainder minus. If you don't want to write minus 1, you say 5. I don't have a problem. But then the answer comes out to be the same. So in the theory, we put it in and we also prove it. It's fine. We have discussed that, I suppose, also. And then, so this is the remainder. And you can see it in any other way also. That's fine. But then 6 is even, so it just becomes 6. Is it now almost clear what is going on? Right? So here we have this quantity, this for simplification, I'm calling it x. The x guy here leaves the remainder 6 factorial mod 7. I can bring this 6 factorial down. Well, why? Let's not worry about it now. Let's say that I can bring it down. Then is the problem complete? Yes? Is this, are you guys following?
Yes, sir.
Right? then the problem is complete. So, I mean, now I will suggest that you take anything. You take 7q plus 1 and do the whole thing for yourself. And see, you will again get the answer. So, homework is just to do that. At least to begin with, try for the other remainders and see that actually nothing changes. There's nothing special about remainder being zero, because cyclically you're going to get the same thing, right? This q will go somewhere in the middle. Right? You start with 7q plus 1, do it and see. Problem is done. But then you have to explain this. Why can you do this? So what you have to just prove is, maybe we can discuss it next time, right? Let's not load all the things in one time. Try for the other remainders. Small arithmetic, it allows you to freely do things like this. And then another homework, please do this, is prove the same problem for n equal to 11. Because if you do this, then you will try and get more intuition. Okay? You'll see that eventually the same questions come up. Why can you divide this? Other things will remain almost the same. Okay? So please do it. We will also prove a theorem from here, okay, which will be very, very handy. So 11 divided. Actually, any prime will work. That is my prime. One homework. And the next homework is show that this is an integer. Again, do it for numbers, anything, but please do something about it. Okay? Show that this is actually an integer. Write it in your own words. A natural number. But we have not proved it so far, right? Prove that it is an integer. It's a good time for us to prove that. Okay. One more homework related to the previous question. Yeah, one more homework related to the previous. Just note this down, then. So fine, noted this. Let me give you the next question. It's a very interesting problem. You take the arrays that you were dealing with, right? The interesting arrays. Yeah, I mean, just take the previous problem. Okay, just take the array of the problem. Take the kind of arrays that were there in the problem. Take the arrays that was there in the problem. Take those arrays, J, odd, and blah blah blah, right? Show that you can rearrange the rows in some way. No, let me not ask you this. This is probably, yeah. Just remove this. If we rearrange the rows in some way and the columns in the same way, I'll give an example of what I mean. You can understand a little bit maybe. Or, I mean, what I mean is you can understand. Well, in the same way, then also we get all distinct on the diagram. And once you do, if you do this, you will see it's pretty underwhelming. But I've given it for some other reason, which will be useful. It can be useful later. What I mean by same way, but same way means that look, if you take an array, I mean, I'm now taking random numbers that I don't give away too much hint. Okay, it could be anything. It doesn't matter. 5, 9. This is what I mean by same way. So let's say that you say I will swap the first and the second row. Then you have to swap the first and the second column also. Okay. So you swap the first and the second row. Let me write it like this: swapping the first and the second row. Okay. So this is one rearrangement, but you could do more complicated rearrangement. But apply the same rearrangement to the columns also after you have done it to the rows. Does it matter whether you do it after or before? That's also an interesting question to think about. Okay, but one at a time, right? So if you if you swap the first and the second row, see what happens. Okay, this is what it mean by swapping the first and second. And so this is 2, right? And the first row comes. Second, the last one doesn't move. But now the deal was you have to apply the same thing to the. See, here it has gotten bad, right? I mean, 129, this becomes 229. Gone. This is not true, right? I will swap do the same thing to the second and the third column. Right, this is just my symbol, and you can, it's like a sensible, simple little bit, right? You'll be using all these things soon, more and more. But second and third column, first and second column also, we have to do the same. Do this. Do you notice something? Not very surprising, but distinct are distinct, right? And those numbers that were there in the diagonal, they are remaining on the diagonal. Okay. So basically, if you do this for any matrix, any array, for anything, now what was there in the diagonal will remain in the diagonal. It may get shuffled, but what was there on the diagonal will remain in the diagonal. Okay. Note this down, and the meeting will end, and that's it. Okay. We'll meet at night. 9:30 is our time, or is it 9? Someone tell me.
So it's 9.
9. So 9. Okay, 9 everybody. Okay. Note this down, then meeting.
So we have class in the night as well.
Yes, 9. Yeah, this week 3 classes. Take some rest and see. If you get the time, take some rest. All right, so I'll leave. Thank you. We had an interesting discussion today. Okay. Take care. Bye.